Hi, we have seen that the electromagnetic field carry energy, and we have calculated the energy density carried by the electromagnetic fields. Electromagnetic fields also carry momentum. Okay, electromagnetic fields um, also carry momentum. The density, the momentum density carried by the electromagnetic fields is given by energy density by velocity. We get this equation by considering the particle nature. Here, if we are considering electromagnetic waves as particles of zero rest mass, we know energy and momentum are related by the relation E equal to Pc or P equal to E by C. So here momentum density, that is equal to energy density by velocity. So momentum density P is equal to U by C, where U is the energy density that we calculated in the previous class. Okay, so the energy flux density or the Poynting vector, the energy per unit area per unit time, that is the Poynting vector, the energy per unit area per unit time. S, the Poynting vector is given by C epsilon 0 E0 square cos square k z minus omega t plus delta unit vector set if the electromagnetic wave is traveling in z direction. And that is equal to C. U is the energy density. So energy density U is epsilon 0 E0 square cos square k z minus omega t plus delta. So that is small u. So here I can write U as equal to S by C. U, energy density, is equal to the Poynting vector or the energy flux density by C. U equal to S by C. So using this, we calculate the momentum density. Momentum density is now equal to S by C square because U is now S by C. So if I substitute here for U, I will get P as equal to S by C square. And the vector form, it will be equal to Poynting vector S by C square. And S we know, that is epsilon 0 E0 square cos square kz minus omega t plus delta by C unit vector set. Okay, so I can write P as equal to U by C. Set the, in vector form, the momentum density is equal to U by CC. U by CC set, unit vector set, if the electromagnetic wave is traveling in z direction. Okay, so these are the expressions for momentum density. Now we are interested in the average value. Actually, the electromagnetic wave, since both the energy density and momentum density and such terms contain this cos square term or cos term. You know, cosine term is a continuously varying one. And for typical electromagnetic waves, this variation is so fast. When you make some measurement, several cycles would have passed, because these cycles have very short time interval, short period. So when you try to make some measurement on the electromagnetic wave, large number of cycles of the electromagnetic wave travel or pass through. So we are interested in the average value. Okay, average value of the energy density, average value of the momentum density, because whenever you make a measurement, you will be getting average value. Okay, the average value of cos square theta, that is equal to half. Okay, if you calculate the average value of cos square theta over a cycle, that will be equal to half. So The U, we know the energy density is equal to epsilon 0 E0 square cos square k z minus omega t plus delta. So average value of the energy density, average value of the energy density. This is what we get when we make a measurement. So that is equal to epsilon 0 E0 square. Average value of cos square k z minus omega t plus delta is half. So that is equal to half epsilon 0 E0 square. Okay. Average value of the Poynting vector or the energy flux density, that is equal to, in same way that is equal to half C epsilon 0 E0 square set. And momentum, we know the expressions for U, S and P, and there we take the average value and we just substitute for average value of cos square as equal to half. So average value of S is this, half C epsilon 0 E0 square unit vector set. Average value of momentum, that will be 1 by 2C epsilon 0 E0 square set. So these are the average values. Then we discuss about the intensity. Intensity is the average power per unit area, average power per unit area transported by an electromagnetic wave. Okay, average power per unit area transported by an electromagnetic wave, that is called the intensity. We know the Poynting vector S is the energy per unit area per unit time. Energy per unit area per unit time. Okay, that is our S, the Poynting vector. So per unit area per unit time, that means energy per time is power. So it is power per unit area. So intensity is actually equal to the Poynting vector. Okay, because S is the energy per unit area per unit time. Energy per unit time is the power. So is the power per unit area. So I is equal to the intensity. I is the intensity, that is equal to the average value of S equal to half C epsilon 0 E0 square. So we have done away with the vector notation because intensity is a scalar quantity. Okay, intensity is a scalar quantity. So we are taking the magnitude of the Poynting vector. So I is equal to average value of the Poynting vector half C epsilon 0 E0 square.